Welcome to the video about Chapter 7. The purpose of this video is to mostly explain the break-even analysis. However, before I explain the break-even analysis, it's important that I at least set the stage for what it is we're talking about here. So in Chapter 7, we are introduced to this idea of process strategy, which means which type of process do we want to use to get our job done. So maybe we're working in a place where we're running an assembly line, like we got the picture here with the old Ford plant. Or maybe we're running a place where produce things one at a time. But nonetheless, we have to decide what type of process strategy we want to use. And we generally do that related to the break-even analysis. How many units do we really want to produce and sell? That will tell us if it's worth it for us to produce in a assembly line versus a single product design. So in this chapter, we're going to have a few process strategies that you're going to need to know and understand so that you can then work some of the problems. So the four basic process strategies are listed here: mass customization, process focus, repetitive focus, and product focus. And if you are looking at the handout that I put with this video, you'll probably see all the way down the right hand side of the page are these, and there's a whole bunch of details about each one of them. So as you might imagine, there are pros and cons and trade-offs and all that stuff with each of these different types of processes. So this video will focus just on those four process strategies and then how those are related to the break-even analysis. So let's just take a look at in a little more detail about how things are made, these different process strategies. This diagram here I think is a great summary of all of this stuff. And basically what it says is that we can produce in one of four ways here. We've got the process strategy, the process focus, where we have low volume and high variety. And then we've got mass customization over here, where we've got high volume and high variety. And then down here we have the product focus, where the product essentially flows through the plant. And here we generate lots of product at a low cost. So we don't have very much variety, we have low variety and high volume. And then kind of in the middle here is this repetitive process, where we have some variety, but pretty high volume, that sort of thing. So here, let's just do the same exact graph here, chart, with pictures. So I like pictures. I think it helps us see things a little bit better. So up here in this high variety, low volume, we've got a process focus. So there it's like a job shop. So you see right there I have pictured a guy that's repairing shoes or leather or something like that. There's lots of ideas, lots of examples of job shops, but it's a place where the people tend to have a trade, if you will. Lots of variety within the jobs. They can do lots of different things, like a plumber would be another example, where they're kind of running a job shop. In the middle there, where we've got the nice blue Subaru car, it's a repetitive process, because cars are made on a repetitive process. They're not quite made on a pure assembly line, or not quite in the high volume matrix as we would call it, because indeed they're made in batches. So they'll make a whole bunch of one particular type of car and then a whole bunch of another type of car. So that's why we call that a repetitive process, and we'll talk a little bit more about that. And then there's the high volume. So in the high volume, these products are made almost continuously. So I have a picture there of a paper mill with all the big pieces of lumber there, and really these products are not differentiated until they're completely made, which makes them very unique, right? Because most other products are differentiated right from the get-go, but not a product that's made in this particular type of environment. And then up here in the right hand corner, my favorite, we've got the Nike plant, right? So this is definitely mass customization, right, where we can write in and say we want this or that type of shoe. So mass customization, that's another alternative that's available to us. So these are the four big types of processes that we would manufacture it. And as you might imagine, this one is going to have a lot of high costs right at the beginning for the equipment and all that stuff. But then the cost per unit is also going to be kind of high. But the cost overall is going to be much less here than it is going to be down here, like for the equipment and the land and the facilities and that sort of stuff. So we need some tool to enable us to determine, you know, which is a better process to have. Do we want to put all the money into all the equipment here, or do we want to put a lot of money into labor maybe here to learn how to do something? And, you know, kind of where do we fall on this continuum? So that's why in this chapter we talk a lot about this notion of break even. So let's just delve into a little bit more detail about each one of these. So the first is the process focus, where we've got the high variety, low volume. So the facilities are all going to be organized around one process, and they're often quite complex. The labor is going to be very high skilled, like a trade or something like that. And the equipment, expensive, but relatively inexpensive compared to, say, the process, you know, for the paper factory, the product focus. So we say that the equipment is general purpose, lower utilization, you know, the machines aren't running all day long. Equipment costs, they're low with respect to fixed costs, I mean relative to everything else, but they have very high variable costs because each unit is going to be very expensive to produce. And some examples: shoe repair, a print shop, a hospital, you know, as well, a plumber, or a refrigerator repairman, or a carpenter, all those things, you know, relatively skilled labor, and lots of different tools that are general purpose, that sort of thing. All right, and then the next one we want to talk about here is the repetitive focus. So this one is like the Subaru car, and remember I told you it's in batches that we make this stuff. So the facilities are organized around this product flow. So the product is flowing through the facility. The equipment is specific and high efficiency, so I mean really specific. It really can only produce one thing. The skill of the labor force is lower, of course, than for the job shop, because these people pretty much do exactly the same thing every day. It's all very scripted. The flexibility is limited, but modules enable some level of flexibility that we haven't always had in these types of shops. And then equipment costs are of course very high, and variable costs are pretty high too, but not maybe say as high as they would be in the job shop. And then some examples: Subaru or appliances, Harley Davidson motorcycles, some of those. All right, and then we move on here to the product focus. So here, like the continuous focus. So in this type of facility, we are pretty much producing non-stop. We have a really high flow of product through the assembly line. The product is not distinguishable until it is produced. We have pretty low skilled labor. It's all pretty automatic. We can automate a lot of these places. Our equipment costs are high, I mean like ridiculously high. And we have very low variable costs to go with our very high fixed costs. And some examples might be paper, sugar, electricity, all of those things. All certainly fall in the continuous focus or product focus. And the big thing to remember here is that the product is flowing through the assembly line. And then the final one here is this mass customization. So this is like the Nike plant, where you can call up and or whatever, go online, and you can order exactly what you want. And in our mass customization plants, facilities typically work in like work cells, because they have to assemble all these sort of unique products. The equipment, of course, is very sophisticated, which makes it expensive. The variable costs are a little lower, but the fixed costs are quite high. The flexibility of the equipment is pretty high considering what they're making. You know, in a regular shoe factory, the flexibility is very low, but in this shoe factory, of course, the flexibility is going to be somewhat higher. And then the labor, again, a little more highly skilled than your typical manufacturing laborer, but not near as highly skilled as like in the job shop or something like that. So now let's just take a look here at this clicker question, if you will. The volume variety matrix is coupled with your knowledge with competitive strategy. Firms competing with what type of a strategy are likely to use what type of a focus. So this is right out of your textbook, where they discuss how to associate some of these different types of product focuses with strategies. And I think that's really important. So I think you should take a look at this and make sure you understand that in this case here, a firm that has a differentiation strategy is much more inclined to use a process strategy than, say, a cost leader. A cost leader probably wouldn't be using a process strategy, and then a response strategy, probably not going to be using a product strategy, probably going to be using mass customization. And a cost leader is going to be a product flow strategy. So take a look at that. You should be able to associate them. The basic idea is that the job shop enables people to create a unique product, whereas the mass assembly line, continuous flow, there's very little variety there going on. So if this is sort of a background, let's take a look at some of these break-even problems and see if we can't tackle them. So we're going to turn to the next page of this handout, but before I do that, I just wanted to draw your attention to a couple things on here. So first is, we're going to go over a little more of this in class, so don't worry about that I'm not covering it. But I did want to draw your attention to the discussion questions, and you'll find that if you do the discussion questions, maybe even before you do this next part of this video, it might make things a little easier. But the discussion questions are designed to sort of reinforce what we were just talking about. It sort of sets up the idea of this break-even analysis. So let's go ahead then and switch to the next page and do a couple of problems here. So a problem like this, a simple break-even analysis, we're just going to look to see how much money we need to make in order to break even. That's all. There's no comparison of different processes. But I teach you this just in order to use this as a platform to then look at different processes. So this is just the basics. You probably learned this in accounting, I would think, and so it's nothing really more than that. So in this problem, ultimately what we're going to do is figure out how many units do we need to sell in order to break even. So I just have a little example here, and we say that the operation has these fixed costs of $10,000. So we'd probably just want to note somewhere that F is going to equal $10,000, and I'm getting that from right here. So we'll just put the words right out here. We'll just do F is going to be 10,000, and we got that from right here. Fixed costs are 10,000. Then it says variable costs, so that's going to be V, and that's $1.50 or 1.5. But I think there's two types of variable costs in this problem. There are variable costs per unit and then variable costs for labor. So really our variable costs aren't just $1.50, they're actually $1.50 plus 75 cents. So let's just note that right here. Do V is going to equal 1.5 plus 0.75, which is 2.25. And I'm getting that from right here, $1.50 per unit plus 75 cents for material. And so, just so you can see that there. So our total variable costs then are $2.25. And then it says that we sell these things, our price is $4. So we'll put $4 here. So then we can easily put this in our equation. We've got our fixed cost of 10,000 divided by our price, which is 4 minus 2.25. So that should give us a break even in units of 5,714.29 units. So we need to sell 5,715 units in order to break even, essentially. This is a fine thing to know. I mean, it's helpful to know this, so we might want to mark this, highlight it, and then sort of note what we have found here, because as you guys know, that this is a really important thing. So we need to write something along the lines of, number of units we need to sell to break even. But we can also convert this over to break even in price, or how many dollars do we need to bring in to break even. Sometimes we might not know exactly how many units we've sold, and so instead it might be easier for us to look at the cash register to see how many dollars we've brought in. So we can do this a couple ways. One way would be to follow this equation right here. So we would just do our 10,000 units. Another equation, we have 10,000 units divided by 1 minus V over P. So V, is 225, same as before, divided by P, which is 4. And then this should give us 22,857.24. So this would be then the break even in dollars. How many dollars of units we need to sell in order to break even. So we might want to note that here. And so I have gone ahead and done that. So now that explains to you how to do the break even in units and the break even in dollars. And then we're going to move on to this next problem. So the first part here, A, is exactly the same as we just did on the previous page. So you should be able to do that without any problem. So I'm going to go ahead and just fill the numbers in here, and then we'll move on to part B, where things get a little more interesting. So once we have that done, let's move on there to part B. So here is how much money are we going to make given these different amounts that we would sell, different amounts of products that we would sell. So let me just show you what I'm talking about here. In the first one there, if we were to sell, I lined out 1,000. So if we were to sell 5,000 units, let's figure out what our profit would be. So we'll write that out right here. So first we write out the price, which is $3. That's how much we sell these things for. And we're going to sell 5,000 of them. So if we didn't have to pay for what we sold, we would just make $15,000 right off the bat. But of course we don't have that luxury, so we have to then back out of it the cost. So we have to back out our fixed costs plus our variable costs times the number of variable costs we have to use. So for this first process here, we pay $5,000 in fixed costs, plus we have to also pay the variable costs associated with that product. And the variable cost for this one is $1.50, I believe. Multiplied by the 5,000 units that we're producing. So with this method here, we would make a profit of 2,500. Now, if we went down here to the second level, so this is if we sold 5,000, and then this one here is going to be if we sell 9,000, how much profit will we make? And so then the second level there at 9,000, we should make $8,500. And then down here finally we have 3 times 12,000 minus 5,000 plus the same thing again, but this times 12,000. And so that should be about $13,000. So you can see that our profit goes up as we make more units. However, at some point it becomes more profitable to use, one process versus the other process. So in this problem, all of part B, we use the same variable cost for each product. But if, for example, we might have a cheaper variable cost with a different process, then it becomes a little more complicated, right? Because here, all of our fixed costs were the same because we're only just looking at one particular process. But down here in part C, what I want you to do is think about if you had two competing processes. So maybe in process A, we have the fixed costs of, let's do it like this, f of A, where our fixed costs then are what we have above, so that's 5,000. And then our fixed cost for process B is this new place, 7,500. But the variable costs at the new place are only $1. And the variable costs, of course, with the other one are still $1.50. So it might become cheaper at some point to use the other process. So one way we can figure that out is to use this formula right here. This is the switching point. So what we do is we take the fixed cost for facility A, and in our case that's going to be 5,000, plus our variable cost for facility A, which is $1.50, and we're going to multiply that by X. So we're essentially going to solve for X. And we're going to set that equal to our fixed cost for our other process, which is 7,500, and plus our variable cost, which is now just 1x. So we just do a little quick algebra here, and I need to zoom this in so I can have a little more space. And we'll just subtract 5,000 from both sides. So over here we end up with 2,500. And we'll move this over here, so we'll essentially subtract 1, so we end up with 0.5x here equals 2,500. And then we just divide 2,500 by 0.5, and we get 5,000. So that means that if we sell less than 5,000 units, we would want to use this process on the left. We would want to use the higher variable cost and the lower fixed cost. And if we do more than 5,000 units, we would want to use the other process B, because we pay less in variable costs. So we want to note that somehow. So maybe something along the lines of this, greater than 5,000, choose process B, and less than 5,000, however you want to do it. Now another way we can do this is by graphing the line. Now essentially what we might do would be to figure out what the total cost would be if we produced 1,000 units and then 10,000 units for each type of process. So what I'm going to do here is just calculate out what the fixed cost would be if we produced 1,000 units with process A, and then if we produced 1,000 units with process B. So this one here will be A, and this will be B. We already know, of course, the fixed costs here are 5,000, and our variable costs are going to be 1.5 times the number of units, so we'll have 1.5 times 1,000 here, and times 10,000 here. And then down here we have a little higher fixed cost. So here we've got 7,500, and our variable costs are a little less. 1 times 10,000. Now we can go ahead over here and calculate what our total profit's going to be. So what I did here was I went ahead and calculated the revenue per product per for each facility. So here the total revenue is going to be $3,000, right? Because we sell 1,000 units at $3 each, so we make 3,000. But we have to take out of that our fixed costs plus our variable costs, and so we end up then with a profit of negative $3,500. If we sell 10,000 units, we make $30,000, but we have $20,000 in variable costs we have to pay. So then we have a profit then of $10,000. And then we're going to do the same thing down here below, where we're going to take our price times our volume. So these things are going to stay the same. They're both going to be 3,000 because 3,000 and then 30,000, because nothing changes in terms of the price. The only thing that's going to change is going to be over here, and that's going to be our fixed costs and our variable costs combination are going to change, right? Because now we've got $1,000 in variable costs here plus 7,500, so we have to subtract off 8,500. So actually here we're going to be more in the hole. And then on this one, 30,000, we're going to have to subtract off our 10,000 plus 7,500. So that's going to be 17,500. So you can see that with the second choice, B, we're going to make a bigger profit of 12,500, whereas in this first one, we're only going to make a profit of 10,000. And then the final step of doing all of this is just to create a little graph to sort of show what we have found. So what you can see here is I have sort of a rough sketch, if you will, of what happens at these various points. We know that the switching point, or the point at which they cross from one being more profitable to the other, is right here at 5,000. And then we know that, and so that's this point. And then we know that the red line is more profitable once we go past 5,000. So that's why it has a steeper slope on it, if you will. And then this one, my line is a little off from my dot there, but you can see that if they sell 10,000 units, then they would be more profitable, if you will, if they went with the red line or the second process, whereas the first process is more profitable in the earlier, lower down parts of the line. So this is sort of a broad introduction to all these things, and I hope you find it helpful, and we will see you in class. And don't forget your handout.